Hello, welcome to a video that goes over the solutions for the practice test for test number 5. And test number 5 will cover sections 6.1 to 6.3. So, if we start with number 1 here, we're asked to simplify the expression, and we have all these conditions we must follow. We'll worry about those conditions in a little bit. But one thing we know for sure is that we don't like radicals in the bottom. And also we see an opportunity to get rid of the 64 and the 4. Or when I say get rid of, like to simplify it. So what you want to do is take the 4 through the whole thing, which you're allowed to do. If you have two separate radicals, you can make it as one big radical. So you wind up getting the 4th root of 16 over x cubed y squared. Now you can go back to two separate radicals. Remember, we're allowed to do this using our properties of exponents. So you have that. And of course that becomes 2 over the 4th root of x cubed y squared. We'll change colors. Now remember, part of the instructions say no radicals in the denominator. Also, no fraction under the radicals. So we couldn't leave it like the 4th root of 16 over x cubed y squared. And also no perfect nth powers. That's why we took the 4th root of 16. So the last thing we have to do here is take the 4th root, or multiply both top and bottom by the 4th root of something to get rid of the radical in the bottom. Well, if you think about it, you want to multiply both top and bottom by the 4th root of xy squared, because x cubed times x gets you x4, y squared times y squared also gets you y4. So the final answer will wind up being 2 times the 4th root of xy squared over xy. So that's number 1. Okay, moving on to number 2. So number 2, what we want to do here is simplify each radical. So you have a cube root of 32. Now remember, 32 is 8 times 4. And 8's a perfect cube. So you can totally pull out a 2, because the cube root of 8 is 2. And also you can pull out a y, because you have the cube root of y5. So it leaves you with the cube root of 4y squared. Again, the cube root of y5 is like saying the cube root of y cubed times y squared. And of course the cube root of y cubed is plain old y. You have the cube root of y squared. So anyway, that's going to be the first radical. For the second radical, you have y on the outside. Now you got 108 inside. Now 108, hopefully you can see it's 27 times 4. The cube root of 27 is 3, so I pull out a 3. You have a cube of x cubed, I pull out an x. And inside you have a 4 and a y squared. So essentially we got 2xy times the cube root of 4y squared and a 3xy with a cube root of 4y squared. So altogether you got 5xy cubed over y squared. So that's number 2. For number 3, actually we saw this in the classwork. You have 2 root x4 up top. Down below you can pull out an 8. And you can pull out an x7. The reason why you can pull out an x7, remember, you have the square of x15. That's the square of x14 times x1. And the square of x14 has to be x7. Because x7 times x7 gets you x14. If we keep going, you get 2x squared up top. And again, down below you got 8x7 root x. You could simplify, or you can get rid of the radical. Doesn't matter what order you do that in. But let's say if we get rid of the radical first, then what's going to happen is we'll have 2x squared root x over 8x8. Why is it 8x8? Well, root x and root x is x, and x7 times x gets us x8. Now we can simplify it. Again, using some new colors here. That becomes 1, that becomes 4, that goes away, and that comes x6. So our answer now becomes root x over 4 x6. Let's look at number 4. 1/2 times 8 root x. Remember, root 16, I'm sorry, I meant to put a 4. Root 16 is 4, not 8. Sorry about that. Minus 1/3 times 5 root x. So you want getting 2 root x minus 5/3 root x. Now, if you find the LCD, 2 is 6/3. So you have 6 root x over 3. Remember, the root x can go in the numerator, because root x is a fraction, just root x over 1. And then here I have 5 root x over 3. So we subtract 6 root x with 5 root x, you just get root x. So the answer is root x over 3. And if you look at all of our answers for 1 through 4, we have satisfied all these conditions. None of our answers had fractions that were not in those terms. We had no fractional exponents. We pulled out any perfect powers. No negative exponents, no radicals denominators, and no fraction under radicals. So that's 1 through 4. Okay, let's look at 5 and 6. Now for number 5, the strategy here is to convert 9 and 27 to powers of 3. Now how do you know what power to convert it to? Why not powers of 2? Why not powers of 4? Why not powers of 5? Well, that's because if I raise, say, 2, 4, 5 to a certain power, I'm not going to be able to easily find what power that is to get me 9. I'm sure 2 to some power could get me 9, but it might be 2 to some really weird decimal. But however, I do know that 9 is 3 squared. And I do know that 27 is 3 cubed. So you get 3 squared raised to the x, so instead of 9 to the x, instead of 9 to the x, we get 3 squared to the x. Instead of 27x minus 2, we get 3 cubed to the x minus 2. So you keep working out, you get 3, 2x equals 3, 3x minus 2. Now because these are the same, these must also be the same. So off to the side here, we're allowed to say that 2x equals 3x minus 2. Move things around, x equals 2. And that makes sense, because if you check your work, you have 9 squared hold on a sec. Looks like I did something wrong. Oh, yikes. Yikes, 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 yikes. Okay. Now you see what I did wrong. That's why you gotta be careful, and that's why you gotta check your work. Okay. That's supposed to be 3x minus 6. Remember, we've got to multiply 3 to the x and 3 to the negative 2. Ah. As you told you, I am a little sick, so I am going to make some mistakes. So if x equals 6. Okay. Well, after checking this is going to be a real pain to do. We guess we could probably use a calculator, but you get 9 to the 6 power equals 27 to the 6 minus 2 power, or you get 9 to the 6 equals 27 to the 4th power. Now if we use the Wabbit, just to make sure, no, won't do an update. 9 to the 6, 27, what's going on here? 27 to the 4. See? They're the same thing. So you know it works. Okay. Let's try another one. So here, you want to convert 2 and 4 to powers of 2. So in this case, well, 2 is already 2 to the 1 power, so we can just leave it alone. Here you get 1 over 2 squared raised to the x. So you have 2x squared plus 1 equals 1 over 2 to 2x. Now, because it's on the bottom, for the right side of the equation, you can put it like this. Remember, negative exponents allow you to flip fractions over. Since these are the same, those must be the same. So x squared plus 1 equals negative 2x. X squared plus 2x plus 1 equals 0. We have x plus 1 equals 0. So of course x equals negative 1. And if you want to check your work, which is always a good idea, didn't leave myself much room to do that, but that's okay. So you have 2 to negative 1 squared plus 1, which will actually just be 1 plus 1, equals 1, or 4 to the negative 1 power. So you get 2 squared equals actually 4, because you have to flip over 4 to the negative 1, and of course 4 equals 4. So we know we did this right. Alright, last 4 problems here. We're asked to perform the function operations, and please ignore those instructions. We never talked about how to find domain for this stuff, so let's not worry about that. We'll worry about that in the second semester. So, here we're asked to add the two functions. That's easy. 4x minus 5 plus x plus 2 squared. But we're also asked to simplify as much as possible, so I'm going to FOIL that. X squared plus 8x minus 1. So that's easy. For our next one, you have g of k of x. So you got to replace x here with whatever k of x is. So instead of 8x to the 1/4, remember, we're replacing x with whatever k of x is. So instead of 8x to the 1/4, you're going to replace x with 16x to 2/3. And actually, let me write down a different color. Okay, now we keep going. You have 8 times 16 to the 1/4. Now remember, you got to multiply these exponents. And 2/3 times 1/4 will be 1/6. You get 2 over 12. That reduces to 1/6. So you have 8 times 2 times x to the 1/6. So it's 16x to the 1/6. Okay. G of x times k of x. So equals 8x to the 1/4 times 16x to 2/3. Well, you got to do 8 times 16, which is 128. And you got to add the exponents, because you got two powers of the same base. X to the 1/4 is being multiplied x to 2/3. So again, when you're multiplying two powers of the same base, you got to add the exponents. Well, off to the side here, 1/4 plus 2/3 will be the same thing as saying 8. I wonder why that thing's there. 8/12 plus, I'm sorry, this is getting really annoying. Okay, 1/4 plus 2/3, that's 3/12 plus 8/12, which should be 11/12. So, you get 128 x 11/12. And then lastly, you get g of x over k of x, so it's 8 x to the 1/4 or 16x to 2/3. So that's 1 over 2, obviously. And we're going to have to subtract the exponent. So one thing you could do is you could write like as 1/2 then times x to the 1/4 minus 2/3. And off to the side here, 1/4 minus 2/3 is 3/12 minus 8/12, which of course is negative 5/12. So, final answer, we 1 over 2, and you want to put x to 5/12 in the bottom because it was a negative exponent. And so that covers all the work. I'm just going to double check everything because I did work this out on a separate piece of paper. Should probably double check for number 5 before I worked it out. Okay, looks like we should be all good. Great. So I hope you guys have a great day. Sorry I couldn't be there. As you can tell from my voice, I'm not feeling very well. And also I've got 2 leaks in my house that I got to attend to. But anyway, have a great day. Go Stanford. Hopefully we'll be in the Rose Bowl. And I will see you guys on Monday or Tuesday for our test. Remember, A and B periods have a test on Monday. D period has a test on Tuesday. And I will be available during office hours, lunch, for A and B periods on Monday and before school for D period on Tuesday. All right. Have a great weekend, and goodbye.